Hi class, welcome to lesson 17. So from today we will talk about the internal forces. Okay, so which will be a new part of the section for this class. So today we will discuss internal force, and next week we will discuss the shear and the moment graph. Okay. So why do we need to know the internal force of the structure? Okay, so as you can see here, we have bridge and a frame, okay, to hold in the attached board. So what's the forces if we cut those structures into different cross section? What's the forces in this different cross section? Okay. And before we calculate the exact internal force, as you can see in the bridge, okay, the cross section thickness decrease from the support and then increase again, and why? Okay. So after today's lecture, you will understand the inner force of a different cross section within the structure, and based on different inner forces, we can select the cross section size. Okay, you will understand why the size change in this way. Okay. So the application of today's lecture, first is when designing a structure member, it's really important to know. It's really important to know the internal forces. Okay, so we can ensure the structure can withstand the loads. Okay, this analysis is typical conducted by cutting and analysis. So here is a beam. Let's assume this is a beam. After the cut, the beam first, it has forces N. We call this axial force. Okay, that's the tension or compression of this frame, and also has the shear. We call this V. That's a force pushing the beam up or down, and also it has a moment. So for each cross section, it should have the three forces. And on the both cross section, the force should be in different direction. Okay. So when we are doing the analysis, what will be the step? Okay. So first, we need cut at a point of interest and decide which side to analysis. And then again, that we always did for this class, draw a free body diagram of the entire structure. Okay. Based on a free body diagram of the whole structure, let's solve the support reaction. Okay. and then draw the free body diagram of the larger side to analysis. We can solve the N, V, and M, okay, movement as a nose at the cart surface. And last step, apply equation of equilibrium. Sum of fx equals to 0, sum of fy equals to 0, sum of m equals to 0, okay, to solve for a nose. Okay, that's a step for this type of problem. So let's see one example. If the loading on the beam is shown in this figure, determine inner force on the point C. Okay, first we need to cut exactly on the C point, because C is a point we would like to study. And then let's draw the free body diagram. We have Bx, By, we have Ay, and let's convert this times 6. And also here is point C. And what's the geometry? This is 3, 3, 4.5, 4.5. Okay, so let's solve the reaction first. Sum of the MA equals to 0, By times 9 plus 18 times 3 equals to 0. We can solve By is actually clockwise. It should be negative force. So we can solve By equals to 6. And then sum of the Fx equals to 0, Bx equals to 0. And then sum of Fy equals to 0. Ay minus 6, which is By, minus 18 equals to 0. You can solve Ay is 24. And then after the cut, okay, let's analysis the red section. C, B, we have By, we have Bx equals 0, By equals to 6. Point C, we have 3 unknowns, NV and M. So what should we do? Let's apply the 3 equation of equilibrium. Sum of x equals to 0, which is By minus n equals to 0. We can get By is 0, and therefore the n is just 0. Okay, so for this problem you don't have always to get started with the sum of the moment. Sometimes if you use sum of fx or fy, it's much more easy. So sum of fy also equals 0, so y minus by, y minus 6 equals 0, and y 6. Sum of moment and point C equals to 0, which is negative m minus 6 times the distance 4.5. M is negative 27. Okay. So we solved all the unknowns at section C. Let's see a problem. In a multi-force member, the member is generally subject to an internal. The answer should be D. Okay, that's what we discussed before. Has 3 unknowns: normal force, shear force, and bending moment. And in the mechanics, okay, the force component way acting tangent to or along the face of the section is called the shear force. So here is this force, we call this force the shear force. Let's see another problem. Example 2. So again, we are giving a loading on the beam as shown on this figure. We want to find the N normal force, shear force, and the moment at point C. So first, we need to cut at point C. And the first thing we need to do is to solve the reaction. Solve the reactions. Okay. Point A, we have AY, AX, okay, and then we have a T, and let's solve it, okay, solve all the reactions. Sum of MA equals to 0, and then we need to convert. Okay. Okay, here's the first step. Hope you get the same answer as me. What we should do next? Okay, next we should analysis a section. Okay. Let's call this is AC, AX, AY. because we are only considered AC, this will be 150 times 3. After the cut, okay, it has VC, NC, and MC. Okay, sum of fx equals 0, which is NC plus AX equals to 0. So AX is what? We already solved AX here. So therefore we can get NC is negative and its compression. Sum of Fy also equals to 0. Equation 3, sum of Fc equals to 0. MC plus 400. Okay, here is answer. Okay, that's pretty much for today.